Hello, everybody. So glad to have you join us here today. We have on the phone with us William Murray and J.J. Webb, both from Cummins. William is a packaging engineer there who received his BS in packaging science from Clemson University. And in his current role, he's had the opportunity to learn about LCA methodology and tools. J.J. Webb is the Global Packaging Engineer Director for Cummins, and her primary focus is working to establish the global packaging engineering function with specific aim on integrating environmentally sustainable packaging design solutions and processes through end-to-end supply chain. So without further ado, I welcome you both.
Thanks, Holly, and thanks everyone for joining today. And as Holly said, my name is JJ, so I'm looking forward to sharing a little bit of what we're learning with packaging design and implementing LCA analysis into our work. So we as packaging professionals, we have a responsibility to ensure that the designs and the solutions that we put in place will have as minimal impact on the environment as possible. And this can be accomplished through using science and data-based LCA applications. So in Cummins, packaging is our second highest contributor to our overall waste that we have coming through our network. And so we've set a 2030 target to reduce 70 million pounds of packaging-related waste throughout our network. And so one of those key enablers is to ensure that we have environmentally friendly design solutions. So thank you for joining us today as we share a little bit about our journey and how we've integrated that into our design selection. Science does show us that as our global population has grown, the way we live as humans is having a highly negative impact on our ecosystem, and the resources that we depend upon are depleting. We are seeing increases in our temperature and increases in extinction. And so basically our climate is changing. So if you hit enter, it brings up the definition of climate change. So just kind of to set a baseline. So what do we mean when we talk about climate change? It's a long-term shift in global or regional climate patterns. And so often climate change refers specifically to the rise in temperatures that we've been seeing from the mid-20th century to present. Our environmental impact. So, what do we mean when we talk about that in relation to climate change and what's happening to our environment? So our environmental impact is the effect that the activities of people and businesses, the businesses we work in, have on our environment. So this shows you graphically, I'd referenced our responsibility in packaging and our impact that we have in our Cummins business. So in Cummins, our manufacturing and packaging scrap together compromises greater than 80%. And you'll see on here in this graph that the packaging are wood, corrugated board, plastic, and non-recyclable packaging at this snapshot in time made up 29% of that. Packaging, LCA, and Cummins. So why did we decide to start using LCA modeling? It started with hearing a lot of different assumptions. And so I worked with our packaging engineers all over the world, and I was hearing a lot of differing opinions in different packaging solutions and material types and which ones were the most environmentally friendly. I would hear that steel is better than wood, or wood is better than some of our corrugated solutions, that the plastic is just something we shouldn't have. And so we wanted to start to test those assumptions and really use data and science to model all of our different packaging options so that we could, maybe break down some of those assumptions and turn them into facts. We wanted to have data-driven decisions versus assumption-based decisions. And this work does align with our company goals. As I said, we've set pretty lofty goals, actually, and targets for 2030 and 2050. And so, the work to really start to incorporate LCA aligns with that. And we were looking to come up with a standard application that would also make sure that we're all looking at the same, our information in the same way, using the same, data and software to help us, analyze our different solutions. I also participate each year in our ISO 14001 series audits, of which LCA, falls into the ISO 1440 piece. So when, talking with the different auditors and really mapping out what our path is going forward and how we're working to continue to drive further and further integration of environmental analysis and life cycle analysis, into our future state plans, that's one of the things that we speak about within the audit. And the auditors are, always really impressed with the way that we're diving into this and how we, truly are working to make sure that we're, using the right data and science for our decisions. So if you hit enter one more time, kind of talking to different types of LCA projects that are different, types of things that you can do with LCA and what we've incorporated into our project. So obviously you can do material comparisons across your different design solutions. And so when you're trying to make a material selection, this really helps you in doing so. You can look at different pack quantities and, working towards environmental, how do you get the right quantities to optimize for the right environmental solution? We're able to map different transportation modes and see how those have an impact on our overall design solutions. And then one that we're finding really helpful is the returnable versus expendable design comparisons. If you're not as familiar with LCA modeling and the outputs that come from this slide is just to help, share a little bit of what you get in your results and what it means. And so the first is your human health or your disability adjusted life years. So that's a measure of the overall disease burden expressed as number of years lost due to ill health, disability, early death. You get a factor on ecosystem, so that's your number of species that may disappear due to the impact, multiplied over the area which they are affected and over the duration that species is affected. There's a nice summary on resources and that category puts a future value on the resources which won't be available, right, in the future. So that's a nice summary. Climate change, carbon dioxide equivalent as measured as kilograms of carbon dioxide. This is one that we monitor and measure a lot within Cummins. Obviously, we produce engines and power solutions. And so the work that we're doing on product, we focus on CO2e, and our packaging impact is a nice way to be able to incorporate that to get a whole picture of that. From a water, counts the amount of water consumed in cubic meters. It's not part of the impact score, but it does give you a really good picture on, how much water does go into the production of this design solution. And it's also something that in Cummins we're focusing on as a key metric. And then you have your cumulative energy demand, so the megajoules that adds up different categories of energy. Okay, so when you're getting ready to prepare to do your LCA modeling, there are a lot of inputs, and it's good and really important to work to gather all those inputs before you get started. So you need to have a good understanding of your material types that go into your design solution, what the processes are, so your carton production, thermoforming, extrusion, the quantities, so your masses, your volumes, your distance. What is your package quantity going to be? How many units of product does the package hold? And you kind of heard me earlier, you can play around with that, right? And see how it impacts your overall final output, your product usage, what quantity of units are being modeled, your transportation modes, both your inbound and your outbound. It's fun to see the models. You can see, the different impacts that you have from those different modes of transportation. You can do mixed transportation modeling in there as well. And then on the returnable expendable, how many times will this packaging be used? And so gathering that data upfront is very important. And all of that feeds in the model into quite an extensive list of midpoints, which then filter into those endpoints that we just went through in the prior slide. So that sets the baseline for kind of all the work and the outputs that you're able to get. With that, I'm going to hand it over to William, and William's going to take you through some examples of some of the modeling that he's been doing with our design solutions in Cummins. William?
All right, thank you, JJ. All right, so I wanted to run through a couple of case studies with you of examples of packaging LCA studies within the automotive manufacturing business. And this first example here is of an injector cup. We produce this injector cup at one of our plants in Columbus, Indiana. It's a very small component of a larger injector, and we send these to many locations throughout the world. And being that this is one small component in a plant that's very busy and does many different things, we had noticed one thing that we were overlooking is that for a while we had been packaging these very inefficiently. So if you see right now in the photos, we've got some examples of the packaging that they go into a plastic tray, and that plastic tray gets wrapped in corrugated, and we stack those up inside of a corrugated box to be sent off. However, we had noticed over time that we were only filling our corrugated boxes up about halfway, not the full capacity of the box. And I tried to get to the root cause of why this was. After finding a few different causes, we were able to address that concern, and we had it set up to where we were now shipping our injector cups in full boxes. We weren't wasting any space shipping air. And we had also made some changes to where we were able to reduce our amount of premium air freight that we needed to ship these by and send them ocean freight. So with those changes, we thought this would be something interesting to look at in the LCA model because, as mentioned, we're filling our boxes more. So that's requiring us to use less corrugated boxes. And we are now shipping via air freight, we're shipping via ocean freight as opposed to the air freight before. Okay, so here is the graph, the inputs or the final outputs that Package Smart gives us once we had put all these details, the full BOM, into the system. And this output graph, if you're not familiar with it, what JJ had just previously gone over, goes over the climate change, energy demand, ecosystems, human health, resources, and water. And it compares the original packaging with the improved packaging, the one where we are increasing our efficiency. The original packaging is the blue bars, and the improved packaging is our teal bars. And you'll see that by making these changes, we saw a significant benefit to our sustainability with this project. We, in all categories from the climate change all the way through the water, we saw reductions in the environmental impact by about 20 to 30% in each category. So if we want to take a little bit of a deeper look into that, if we go over to the next slide. So this slide breaks it up now into two separate graphs. On the left side, we've got a graph showing our original packaging, and on the right, we've got the graph showing our updated, improved packaging. And you'll see here that it's got different colors on the graph showing what impacts are coming from the materials, what impacts are coming from the conversions. And it's also got the distribution and the end of life. So you see in the original packaging, we had a very large portion of our impact was coming from the distribution. And seeing how we changed that from air freight to sea freight, now the yellow color, the distribution, has become significantly less over into the new packaging. So that's just one example of looking at some different packaging techniques within our automotive packaging world and looking at it through LCA lens, as opposed to just making an assumption and then looking at just how much overall kilograms of material that we reduce. This gives us a more data-driven answer to our question. So if we go over to the next slide. So one big area of the automotive packaging sector would be returnable packaging. If you're not familiar with returnable packaging, it's just simply a package that we would use multiple times, hopefully as much as possible, that we would fill up at one location and send to another. They would use the packaging there, remove the product, and then send it back to us to be used again. So as JJ was talking about, we like to make a lot of assumptions, and with returnable packaging, we had always assumed that, you know, anytime we switch to a returnable, it's automatically better for the environment, because we're using less expendable material. We don't need to get rid of as much wood or corrugated. So in this example, this is our 95-liter engine. This is the largest engine that we produce at Cummins, again, made in Indiana. And we were considering this for a project to make a returnable package between Indiana and one of our customers in California. So when modeling a returnable package in LCA, there are three key factors that you want to look at. The first one being transportation. So obviously, as we saw in our last slides, transportation has a significant impact on the LCA modeling. And now with returnable packaging, we're not just considering the LCA model of taking the packaging and the product to the end user and it being disposed of there. Now we have to send it back to our location. In this example, over 2,000 miles between Indiana and California, and then being used again, and doing that many, many, many times over, as opposed to an expendable that we would just use one time, have it disposed of in California, and that'd be the end of it. The second important factor would be the lifespan. So the lifespan of the packaging material it has a significant impact on how you're going to model in the system. So for example, if you have a material that is like steel, in this example that we were looking at, a steel returnable pallet, that may last much longer than a plastic returnable pallet, or even trying to reuse wooden material. So the material type, the type of package it is, whether it's a pallet, a tote, a bulk bin, and the type of product that's going inside it. If it's a very heavy product versus a light product, that might have an impact on how long the returnable packaging can last. And finally is the distribution environment, how it's going to be transported. Will the handling be rough on the packaging to cause it to wear down more quickly over time? And so that would be the lifespan. And with that, you're trying to determine how many uses of a returnable do you need to have the same impact as an expendable. So that's our last significant factor, is the volume. So what amount of returnables are you replacing with what amount of expendable? So for example, in this case, we needed to figure out how many returnable packages, how many of these steel pallets would we need to buy in order to have a loop where we wouldn't run short of sending the pallets back and forth between the locations, where we wouldn't run out. So with these three key factors, you're able to adjust the LCA modeling to where you now have a returnable system as opposed to the expendable. So if we go over to the next slide. So here you can see some of our modeling that we did of the steel versus the returnable, the steel there on the left side. And you can see that in this BOM in Package Smart, we actually had a separate line item for the solely for the reverse logistics of the pallet. and there's a quantity there and 78, and I will explain that. The question is, why are we using it 78 times? So if we go over to the next slide. So again, we have two graphs here, some outputs from Package Smart we're looking at. The graph on the left is the single score, and what the single score does is it adds up each of the previous categories into just an overall impact to the environment. And so that's 78 uses, or 78 would be from one location, point A to point B. So 39 would actually be from A to B and back to A. We have 39 uses of the pallet it takes for a returnable pallet to equal that of an expendable pallet. If you look over at the graph on the right side, that will show a further breakdown of each of the individual impacts. You can see that the expendable pallet in blue had a much more significant impact on the energy demand. And in this normalization graph, that's part of the reason why the single score for the expendable is so high. But now with the returnable pallet and the expendable pallet needing 39 uses to equal each other, we now can say, all right, based on our volumes, do we want to go with the returnable pallet, knowing that we need to use it 39 times to equal the expendable pallet, or should we just continue to use expendable pallets? So if we go to the next slide, here again, we will see just the breakdown of the returnable pallet itself. So this is showing that the distribution, that amount of transportation, that additional transportation, sending something back to its location to be used again plays an impact on that end outcome that we're seeing. So the distribution ranges from 25 to 55% in the climate change, energy demand, and human health. So I want to end by saying it's important to know your goals. Sometimes LCA answers are not simple. So again, here we're looking at the same graph from a couple slides ago, but you see in the normalization impacts, comparing this expendable versus the returnable, there's some categories where the expendable pallet is better, and we have some categories where the returnable pallet is better. Like we said, sometimes LCA answers aren't simple. You need to know your goals, what you're trying to accomplish. Maybe you're focused on the climate change. Maybe in this case, you would want to use the expendable pallet because it has less impact on the climate change, or maybe it's on the energy demand, in which case you would want to use the returnable pallet. So the other points we have here are find a LCA software that meets your needs. We have been using Package Smart for a couple of years now. Again, we're by no means LCA experts, but we found that it's very user-friendly and easy to upload our bombs and get our outputs relatively quickly. And then with that being said, the other factor is what level of accuracy you can achieve. So as JJ mentioned a few slides ago, there's a lot of inputs that are needed up front. And the more of those you can get, the more accurate your modeling can be. So it's important to have a software that you can use and to make sure that you're doing your work up front to get very accurate modeling to get some good results. So with that, I'll turn it back over to JJ.
So in summary, lessons learned. We've certainly learned over the last couple of years that we were making some incorrect assumptions. So there's continual learning that's coming through that. Actually, I think we wouldn't you say, William, we learn something with each new model that we create. LCA modeling applications, you know, it's not easy. It does take study and it does take practice. You know, it's been great working with the EarthShift global team because they are always right at the ready to help us and teach us and answer our questions. You do need to map out that full bill of material in your whole supply chain in advance. If you'll lean into that work and do that up front, you know, that's just going to make the whole process flow much better and easier for you. Again, there are many different comparative analyses that can be completed, with the modeling, and it's really always very interesting to see the outputs from that. We compared, just in transparency, we compared a few different softwares before, settling in on PackageSmart, and they each work a little bit different and could be unique in their own ways, and so they're not all the same. So you do have to be selective in what you choose, and we found PackageSmart to be a good solution for us. So with that, are there any questions?
Well, thank you, JJ and William. We do have some questions, and I'm taking more questions if people want to send them to me privately. But the first question I have is, are there any rules of thumb that you've been able to learn from your work?
If we're talking about packaging materials just in general, what we've seen in PackageSmart, obviously the weight has a big factor in what the environmental impact is going to be. Well, we were recently looking at an example where we were comparing a plastic pallet versus a wooden pallet that was being shipped from Europe over to the U.S. And again, we were making that assumption always that plastic is bad if it's single use. But in this case, the weight of the wooden pallet was so much more than the plastic pallet. It showed that there could be some potential benefit to using a very lightweight plastic pallet. Again, so not advocating for one type of product over another, one type of material over another, just saying that, again, don't make assumptions, and that each product, each package that you're going to look at has different technicalities to it, and different other factors with it that could lead to outcomes that you're not expecting. So I guess, in short, not making assumptions.
Well, thank you. Someone says, what are the boundary conditions of the 29% LCA of packaging, and does it include the lifetime of the engine?
So that one goes back to the pie chart in regards to the packaging waste. Is that right?
I can't tell you.
Okay, so I think that's where that came from on the 29%. So what this figure is, across our whole Cummins network worldwide, we report how much waste material that we put into, or that we have to manage, and kind of at the end of its life cycle within Cummins. And so I guess one key point on this is that this packaging waste here that we call waste is actually all recycled, with the exception of a very small portion of non-recycled content, which would go to incineration for the generation of power. We've been working for zero disposal, and so we segregate our wood and our paper and corrugated and plastic, and that gets reported and tracked, through each location. So we have really good data in regards to the amount of waste that we're managing, and so but our aim in Cummins is to greatly reduce that. And so we do have a fair amount of expendable one-time use packaging in our network, and so we've got a lot of work that we're undertaking. This is where LCA modeling is very helpful as well, to convert from the expendable to the returnable packaging solutions, for the future, which obviously the more reuse you can get with your packaging design solutions, the better that is for the environment. So hopefully that answers what the 29% is. But,
Thank you.
It's reported waste, anyway, that goes into recycling.
Okay.
I do want to point out, I guess, on this graph, we have a category that's called general refuse right next to that. And that would be the material that we're still working to manage that ends up, not going into recycling. And so, we have constant efforts to, and it's not necessarily packaging in that category. There's a lot of manufacturer waste and other just business waste that we focus in on in that little blue piece of the pie. But we have the nice red section to work on.
Okay, another question is, how long does each study take?
Well, I
All
would
right,
say
William, I'll let you, yeah.
it's very dependent on what you're modeling. You know, as I was just talking about a second ago, when we're modeling just one pallet versus one pallet of different material types, that one, you know, can be fairly quick. You can get some baseline data and information that you need maybe within a week's time, communicating with different people on what some of those inputs are. If you're trying to do a more complex system where you've got a tertiary packaging as a pallet, and then you've got secondary packaging, primary packaging, different dunnage types, and you're comparing two different methods, and they could be going from different places, and you've got different logistics inputs. That one could take a lot longer to get everything that you need, and maybe weeks, even months time to get all the communication together to get everything you need. So again, very dependent on what you're modeling, but it could be weeks to months. I'm sure for very complex ones, multiple months. So that's what we've generally seen.
Okay.
William, would it be fair to state that when you first started doing your modeling in LCA, it took a little bit longer because you were new, and as you got more practiced at it, that the time to do the model and knowing what you needed to input into that model, you know, reduced over time with your growing experience?
Yes, that has certainly helped. When I first started, I didn't know a whole lot about what I was doing, and it took a long time just to do even a simple one, I guess I would say. But now, as we've done them much more, we've gotten quicker about getting them finished.
The other thing is you'll end up with some maybe foundational base models that can use as a foundation to help reduce some of the time to do modeling as well, if you've got something that's a similar model you've already done in the past, right?
Right.
Yeah.
So this next question is kind of a suggestion. It says, could you collaborate with your customers so they could use your reusable pallets for shipping their products?
Oh, absolutely, and we do that.
Oh, good. Good to hear. What is the most interesting learning so far from your modeling?
There's been a lot.
Do we want to bring up the PET versus PVC
I was
discussion?
wondering about that. So we actually spent some time really analyzing the different types of plastic materials and you know what the impact was in those. And so yeah, I don't know, William, you want to spend a little time talking about our fun scientific investigation into the world of plastic?
Right. Well, it's I guess some of our assumptions here is that PVC is always worse than PET, and we've kind of made that a point to where anytime we find PVC material being used, we try and see what we can do to replace it with PET potentially. So we've been told for a long time that PVC is bad, PET is better, and we should strive to use that. A major reason for that being is that in the U.S., we do not recycle much PVC. However, in other locations around the world, that is something that can be recycled. So we were looking at it in PackageSmart to see what the LCA modeling said, and it turns out that really the impacts that, other than the end of life with the recycling, the impacts of climate change and energy demand, all of those things were much more greater for PET than they were for PVC. PVC was having less impact on the environment. So that just brought up a very great discussion within our team. We involved our HSE people. We were trying to figure out, why this is. Why are we saying that PVC is always bad when maybe LCA modeling is showing that it's not as bad as we think it is? It's not something that we really, I guess, have an answer to yet, other than the fact that, like I said, we can't recycle PVC. So we still would prefer not to use that. And again, just showing that sometimes LCA, the answer is not just a simple this or that. There's other factors to consider.
And a little more on that one are, as we started to look at, we pulled in some of our environmental and waste experts and Cummins and started to look at this one a little bit more heavily. And so looking at the recycling companies' capabilities in the U.S. and the complexities that PVC has when you try to recycle, because it basically sinks to the bottom, right, in the processing and causes issues for the equipment. But in India, for example, we have operations in India, and the recycling methods in India are different, and so they don't have the challenges with recycling PVC that we have here in the United States. So that was a really fun, fascinating learning for us. We aren't changing our design materials because of that, because you do have to consider, the whole of your life cycle and what happens at the end of your life cycle as well, right? And so the recyclability of your solutions, because everything eventually does reach an end of life, at some point, is very important depending on the region of the world, that you're working and operating in. So all that factors into our material selections and design decisions.
Okay, and are there other factors that you use to make a final design decision outside of LCA?
Yeah, absolutely. And we were obviously making a lot of design decisions before we, embarked on our journey with LCA. And so LCA and the environmental impact is now one more factor we've added to our design solution decisions. Of course, the performance of your packaging solution is a key factor. The cost of your solutions is another key factor. We weigh in this environmental aspect of the solution, and so we add many different things together, even your how the design solutions work through your manufacturing and warehousing operations. If it's a design solution, we also working with customers. Does it work with them? And so there's a lot of inputs that would come into the final decision on what we move forward with.
And so
the
what
LCA has been an insightful discussion, even with, because I think William on that 95 liter, you guys had conversations with our customer about that one and kind of, shared that information as well. So it can be kind of eye-opening to the other parties that aren't necessarily used to looking at it through that lens.
What were you using to show environmental impact prior to your LCA modeling?
You want me to take that one, William, or do you want to?
I can take it. Really before LCA, and still, as we've mentioned, we're not LCA experts yet. It's something that we're still trying to work into our standard work for packaging design. But really before LCA, everything is just based on kilograms of material that we have reduced.
So this was a big eye-opener, huh? Oh yeah, the data and science-based perspective was a lot different. Prior you'd get, you'd look at the amount of material that you would reduce by weight, and then you can stick that out there into some of those standard modelers that you can find out there on the internet. That will compute things into how many trees you save or things like that. But this is a more science-based approach is certainly preferential.
Okay, well, I want to thank you both for this webinar. I know we had some technical difficulties, but we were able to overcome them. I'd like to invite everybody to our next webinar, which is next month at this time, called Dismantling the Green Machine, a critical reflection on the limits of eco-efficient technology. And that's by our senior analyst, Nathan Ayers from EarthShift Global. So thank you again and have a great day. I'm going to end this webinar, everybody.
Thank you.
Thank you, everyone.